Okay. My goal is to keep these videos short, but explain enough of each problem that you get a good sense of how to do it, or remember how to do it. For part A, number 1, you have to factor and solve the following polynomials. So, with factoring and solving anything, you have to get everything over to one side and get it equal to 0. Then because we have 4 terms, we factor by grouping. So group the first 2, group the last 2, pull out the greatest common factor in each grouping. Then you end up getting this when you put the greatest common factors together, and the x plus 3. This will break down even more because that's the difference of squares into 3x plus 2 and 3x minus 2. And then if you take each of those and set them equal to 0, you get those 3 answers, plus or minus 2/3 and negative 3. For number 2, you have 2 problems to do here. You have one account that's compounded monthly and a second account that's compounded continuously. So the compounded monthly type of situation uses the regular compound interest formula. Compounded continuously is the PERT formula. Same amount of money is put in, 2 different interest rates, and then when you punch out each of the values, you get those 2 numbers. Okay, for number 3, to graph the following function, this is a square root function. We use 0, 1, and 4 because those are numbers that are easy to take the square root of. When you plug those in, you get 0, -2, -4. So I graph those, moved them left 3 and down 5, and then my domain is x values greater than -3 because that's what's existing on my graph. And y values are less than or equal to -5. Okay. For number 4, when you have 2 points, you have to write the equation of a line. You start by stack and subtract to get your slope, and then you can use either one of those points. I use the first one and put it into the point slope form. Then I distribute the -7/3 through. This is technically -5/1. So when you multiply fractions together, you multiply across the top and the bottom. Then I subtracted 4, which technically then I had to subtract -12/3. So I had to get common denominators between -4 and 35/3, which got me 23/3 as my y-intercept. Number 5, this is an absolute value function, which means the graph has to be a V-shape. You can use -1, 0, 1 in your table. This shifts right 2 and down 4. Domain is all reals, and the y values are greater than -4. For number 6, there was a typo here. This should have been 3x squared, which most of you caught on to that fact. We start by moving c to the other side. Then because we have to complete the square, you have to divide everything by a. Then we take half of b, which is 3/2, square it, which is 9/4. Add that to both sides. Then remember the pattern, whatever half of b was, that's what goes in the parentheses when you factor. Then you take the square root of both sides. And the square root of 4 is 2, that's how that became 2. And then we solve for x by subtracting 3/2 from both sides. Okay. Number 7, this is an exponential function. We can use -1, 0, 1. When I plug -1 in, the -1 flips that 2 to make 1/2. 1/2 times 2 is 1. Plug in 0, anything to 0 power is 1. 1 times 2 is 2. Plug in 1, 2 to the first is 2. 2 times 2 is 4. I plot those 3 points, shift them right 2 and up 4. My domain is all reals. My range is y values greater than 4. Keep in mind with exponentials and with logarithms, you have to have your asymptote drawn in, so you have a guide to draw your graph. Okay, number 8. We have to solve this one by factoring, so we have to move everything over to one side and get it equal to 0. When you do that, this is a quadratic, so we start by multiplying a and c together to get 100. We need the 2 numbers that multiply to get 100 and add to get 20. Those 2 numbers are 10 and 10. Those 2 numbers replace the middle term. Then I factor by grouping, much like we did before, and you should get -5/2 as an answer twice. So that's what the dr means, is double root. Okay, for number 9, synthetic division. We put the c value, which is technically -2, in a box off to the left. You list your coefficients. We are missing our x² term, so we have to have the 0 there. Bring down the first value. -2 times 4 is -8. Add. -2 times -11 is 22. Add. So forth and so on, and you end up getting that as your answer. Keep in mind that the last number is your remainder, and then it goes up from there, so this is your constant, your x² and your x³. You also have to do long division with the same problem. So we set up putting 0x squared as a placeholder. We asked ourselves the question, what times x gives me 4x to the fourth? The answer was 4x cubed, so 4x cubed times x gives me 4x to the fourth. 4x cubed times 2 gives me that 8x cubed. Then I subtract. Then you go back up to the top. What times x gives me negative 11x cubed, negative 11x squared. So let's look at that. And then negative 11x squared times 2 gives me negative 22x squared. Subtract. And that pattern keeps going until you get to the remainder, which is 79. And you would get the same answer. Okay. Number 10. To solve logarithms, you have to first isolate the log term. So I had to move 5 over and then divide by 2. To get rid of the log, you have to use the opposite function, which is an exponential. So we exponentiate both sides with a base of 4. So those cancel, leaving me with x plus 2. And then 4 to the 15 halves is that number there. And then I solve for x by subtracting 2. For number 11, we had to write a rule for the following sequence. My common ratio was 3 because 6 divided by 2 is 3, 18 divided by 6 is 3, 54 divided by 18 is 3. And then 2 is my first term, so this is my a sub 1 times r to the n minus 1. That's my rule. Then I had to find the value of s sub 30, so that's finding the sum of the first 30 terms in my sequence. A sub 1, the top is 1 minus r to the n, where n is my number of terms that I'm adding up. So 3 to the 30th, and then 1 minus 3 on the bottom. Punching that out on a calculator will give me that value. Number 12. We have to use the height model to set this up. S of t is my desired height. I want it to hit 423. My v sub o is my initial velocity. I'm throwing it down at a speed of 12, so that's why it's negative 12. And s sub o is my original height, so that's why that's 1200. Then to solve this, I'm going to use the quadratic formula, but I first have to move the 423 over, and then plug in a, b, and c into the quadratic formula, and you end up getting 6.6 as the answer. That makes sense there. Okay, for 13, you're forming compositions. So we have to start first by plugging 2x plus 1 in for x in the original function, and then to simplify, 2x minus 1 squared means 2x1 times itself. So I FOIL those out, and then add the 1 and negative 3 together to get that. So f of g of x ends up being that function. Then g of x, we're plugging 2x minus 1 into itself. Distribute the 2 through. Then negative 2 plus negative 1 gives me negative 3. Flipping. Number 14. To simplify complex numbers, we have to, especially when you're dividing, you have to multiply the top and the bottom by the conjugate, which in this case is 2 minus 5i, because the conjugate is the same thing as the bottom, just switch the sign in the middle. FOIL across the top, you get 8 minus 20i minus 6i plus 15i squared. FOIL across the bottom, you get 4 minus 25i squared. Keep in mind that I squared is actually equal to negative 1. So this becomes a negative 15 plus an 8. That's where I get this negative 7. And then on the bottom, this becomes positive 25. So 4 plus 25 gives me 29. And then you can, if you want to, split it up into two separate fractions. Okay, for number 15, we sketched 480 all the way around, and then we have 120 degrees left to sketch. Two coterminals, I add and subtract 360. Reference angle, the space between the x-axis and my terminating side is 60 degrees. Then for 16, expand the following binomial using the binomial theorem. I have to use the fourth row of Pascal's triangle. That's where this 1, 4, 6, 4, 1 comes from. First term, 3x, starts with an exponent of 4 and then decreases for each term. 4y starts with a degree of 0 and then increases each term. Keep in mind when you're figuring out, especially the numbers here, that, like in this case, 3 cubed is 27. That 27 has to be multiplied by this 4 and this 4. That's where I get the 432. So make sure you exponentiate it correctly and then multiply by all the other numbers in that term. Okay, that concludes the first video. I think I kept it under 10 minutes.